Good morning, students. Today I am going to explain the topic second order differential operator, Laplacian operator. Now, after completion of this topic, student will be able to use the Laplacian operator. Now, we are going to define the Laplacian operator, that is second order differential operator. It is a two-folded application of the operator del to a function. Now, del square is equal to del dot del, that is equal to dou square by dou x square plus dou square by dou y square plus dou square by dou z square is called the Laplacian operator. Now we have to, on this Laplacian operator, we have to apply a function, scalar point function f. Now suppose f is any scalar point function, consider del square f is equal to del dot of del f. Del dot of del f, that is equal to del f means grad f is equal to I dou f by dou x plus j dou f by dou y plus k dou f by dou z, and again del is equal to I dou by dou x plus j dou by dou y plus k dou by dou z dot of del f means I dou f by dou x plus j dou f by dou y plus k dou f by dou z. Here dot product takes place, that is a bar dot b bar is equal to a1 b1 plus a2 b2 plus a3 b3. In the similar phenomena, we are going to explain this one. Dou by dou x dot of dou f by dou x plus dou by dou y of dou f by dou y plus dou by dou z of dou f by dou z, that is equal to dou square f by dou x square plus dou square f by dou y square plus dou square by dou z square, that is del square f. This scalar differential operator del square is known as Laplacian operator. And some of the important notes that you have to note here, that you have to apply this one is anywhere. Del cross del f is equal to 0, del dot of del cross a bar is equal to 0, del cross of del dot a bar is equal to del of dot of a bar minus del square a bar. Now, we have to define the Laplacian equation, harmonic function and potential surface. Now, del square pi is equal to del dot del pi, that is equal to div of grad pi. Del square pi is equal to 0, then pi is said to satisfy Laplacian equation. Then this pi is called harmonic function. And again, del square pi is equal to 0, pi is a harmonic function and pi of x comma y comma z is a constant function. Then the surface represented pi is called potential surface. Now let us defining a result. If del square pi is equal to 0, then del pi is both solenoidal and as well as irrotational. We know that curl of grad pi is equal to del cross del pi is equal to 0. That means del cross del pi is equal to 0 means curl of del pi is equal to 0. Curl of del pi is equal to 0 means del pi is always irrotational. And again we know that div of grad pi is equal to del dot of del pi is equal to 0. That means div of del pi is equal to 0, therefore del pi is solenoidal. In both cases, del pi is solenoidal and as well as irrotational. And again, we move into some problems related on Laplacian operator. If r is equal to root over x square plus y square plus z square, then show that del square of r power n is equal to n into n plus 1 r power n minus 2, and hence deduce that del square of 1 by r is equal to 0 except at r is equal to 0. Let us take that r bar is equal to xi bar plus yj bar plus zk bar, and r square is equal to x square plus y square plus z square, and r is equal to, given that r is equal to root over x square plus y square plus z square. Now differentiating partially with respect to x, with respect to y and with respect to z. Therefore, dou r by dou x is equal to x by r, dou r by dou y is equal to y by r, dou r by dou z is equal to z by r. Now let us taking that pi is equal to given r power n. Pi is equal to r power, so that dou pi by dou x is equal to, differentiating partially with respect to x, n into r power n minus 1 into dou r by dou x. Dou r by dou x value is equal to x by r. Therefore, we have to write n into r power n minus 1 into x by r, that is equal to n into r power n minus 2 into x. And again differentiating partially with respect to x, that is dou square pi by dou x square, that is equal to n into r power n minus 2 plus n into n minus 2 r power n minus 3 into dou r by dou x. Dou r by dou x into x, that is equal to n into r power n minus 2 plus n into n minus 2 r power n minus 4 into x square. Similarly, dou square pi by dou y square is equal to n into r power n minus 2 plus n into n minus 2 r power n minus 4 into y square. Similarly, dou square pi by dou z square is equal to n into r power n minus 2 plus n into n minus 2 r power n minus 4 x square. Now adding all these one that we have to take place, del square pi is equal to dou square pi by dou x square of r power n, dou square pi by dou y square of r power n, dou square pi by dou y square of r power n. Adding left side and both sides and the previous equations that we have to take place, 3 into n power r minus 2 plus n into n minus 2 r power n minus 4. First take the x square, second one y square, third one z square. Now already we know that x square plus y square plus z square is equal to r square. That again you have to substitute there. 3n into r power n minus 2 plus n into n minus 2 r power n minus 2. Take n into r power n minus 2 as a common term. Therefore we have to write this one, n into r power n minus 2 of 3 plus n minus 2. That is 3 minus 2 is equal to 1. Therefore finally we have n into n plus 1 r power n minus 2. Now taking that or setting n is equal to minus 1 in the given above, therefore we have del square of 1 by r is equal to n is equal to minus 1 means minus 1 plus 1 is equal to 0. Therefore this value is equal to 0 if r is not equal to 0. Now we move into the next problem.